Uh, Hello friends and welcome to my IoT smart farm system. This is a system that monitor environmental conditions within a greenhouse environment, take control measures to ensure that such conditions are maintained within a given threshold. So the first thing that this system does is to automatically measure the environmental conditions like humidity, temperature, soil moisture, and the lighting conditions within the uh, within the greenhouse, and then thereafter take the control actions, which may include things like starting a DC fan to cool the environment, or even starting an irrigation pump in order to water the greenhouse. Apart from that, we can have things like lighting or turning on lights to ensure that the lighting within the environment is well taken care of, and plants can photosynthesize throughout the day. Apart from that, this system automatically measures the water level in the irrigation tank and notify the farmer when it goes low. Again, it allows the farmer to it allows the farmer to be able to receive the sensed value real time through monitoring on the cloud platform or through SMS. This system has security features integrated with it, and as a result of that, we are able to monitor intrusion into the farm and take necessary actions to ensure that such intrusions are attended to in the right time. Again, we are able to notify the farmer on the current conditions within the farm, and the actions that have been taken to mitigate the same. For instance, you can say soil moisture low, tank volume high, pump on. So with that, the farmer is well informed of whatever condition that is going on within the farm. And again, all the monitoring can be done both locally and remotely. So we have an LCD display where somebody who is present locally at the farm is equally able to monitor such conditions, and even the control actions that have been taken into place. Again, we push the mentioned sense values to the Thingsboard cloud for analytics and equally for monitoring purposes. So that is just a quick overview of how the smart farm system works. And basically, our target audience is greenhouse farmers, or small scale to large scale open field farmers, and it can equally be scaled for plantation farming if need be, so that it can assist such farmers mechanize and control their agricultural processes. So quickly into the demo. The heart of this system is a microcontroller, which is called Arduino Nano 33 IoT microcontroller. This is a microcontroller based on the SAMD21 Arduino microcontroller family, and basically it's a low power microcontroller which has a microchip, a chipset, allowing it to connect to the Wi-Fi. So this Wi-Fi module is actually called Wi-Fi NINA W10 Wi-Fi module, which operates on at a frequency of about 2.4 gigahertz, and can operate on 5 volts power supply. Apart from that, it is the heart of the system. Apart from that, we have light dependent resistor over here. Light dependent resistor is basically a resistor that works on the principle of photo. Basically, when light shines on light dependent resistor, then electrons are moved from the valence band to conduction band. As a result of that, the resistance of the material decreases and can allow current to pass through. So its resistance is actually inversely proportional to the luminous intensity. Again, this is the LDR sensor is what will actuate our light lamp. Our light lamp here is a yellow LED, which will turn on when luminous intensity within the fan goes below a set threshold of 300 candelas. Apart from that, I have DHT11 temperature humidity sensor, which basically assists us to measure both temperature and humidity of the farm. And for that case, when temperature is below a given when both temperature and humidity are below threshold, which for my case is 75% for humidity and 25 degrees centigrade for temperature, then the fan automatically remains off. But above that threshold, my fan goes on to cool, to bring a cooling impact within the greenhouse. The next component that I have is the security system. So the security system consists of PR motion sensor. So PR motion sensor uses infrared radiations from living organisms to be able to detect motion. So when a person passes in range of the Fresnel zone of the PR motion sensor, then what happens is it will detect the radiation, and as a result of that, the pin will go high and will trigger an intrusion alarm. So when anybody passes over there, then my alarm, my red LED here, which is security status LED, will go high and will light. The next LED I have is green LED, which basically is a tank status LED. So when the tank is low, like for now, the LED will keep lighting at about a frequency of about 5 seconds. And then the next thing is a sensor called ultrasonic sensor, which basically measures the level of tank. For this case, I'm using a small container here as a model for my tank. So this sensor is mounted at the top of the tank and is able to measure the distance from the top to the bottom. Remember, this sensor operates uses ultrasonic sounds, ultrasonic waves. So when it radiates, then the moment there's a change in medium, then there's a reflection back to the sensor, and with that we are able to measure the distance traveled by the ultrasonic signals. So with that, when there's water in the tank, then remember it will intercept the signal before it hits the bottom of the tank, and with that we are able to gauge the height of water in that tank, and from that we are able to measure the volume of water in the tank to allow us to carry out irrigation purposes. Next thing is a solid state relay, which is basically an 8-channel SRD 5 volt DC SLC relay. So this relay basically accepts low control input signals from the Arduino microcontroller in order to switch high power systems like 12 volts DC pump and even the 5 volt DC fan. So it will take an input of 3.3 volts from the controller in order to switch such loads. And the next thing is the DC pump, which is basically a water pump that allows us to irrigate the farm. And the farm, it operates on 12 volts power DC power supply. And then apart from that, I have with me my LCD display here, which basically does display for local monitoring, so that somebody just present within the farm is equally able to know or to see whatever is happening in the farm and the control actions that have been taken. And with that, maybe the last component that I have with me is the SIM800L, which is basically a GSM SIM module that allows us to do both SMS, voice, and even GPRS connection to the internet. So with this, we are able to send notification to the farm and even make phone calls for critical conditions in the farm. For example, if intrusion has been detected, then this module is able to call the farmer real time and notify the farmer also through SMS that intrusion has been detected, and so there is need for remedy to be taken into consideration to solve that intrusion. And that's it. So on to the demo. Over here, sorry, I forgot to mention this, is just an inverter, which basically inverts inverse the power supply back from AC to 3 to 40 volts to about 12 volts power supply, so that I'm able to supply my DC component, DC loads here. So onto the demo. I start with the sensor. Currently, lighting conditions in the room is quite well, so my light lamp is off. But when I cover over my light dependent resistor, you will get to notice what will happen. My light lamp here should go on, indicating that luminous intensity is low, and as a result of that, the light has gone on in order to allow the plant's photosynthesis. And you can see over here, actually the pump is on. Sorry, the light lamp is on. So that's how it works. Now it will detect the luminous intensity is high, and in a few seconds it should go off. And there we go, it's now off because it's now detecting enough lighting within the room. The next thing is DHT11 sensor measures both atmospheric and humidity and temperature. So at the moment, the atmospheric humidity, if I just check from my dashboard, it's about a minute. The atmospheric humidity is about 60%, and this is real time. So when I touch on it, it will rise to a higher value. It's risen now to 80. And remember, we have a threshold condition for both atmospheric humidity and temperature, for which our DC fan should go on to cool the environment. So it should be at 25 degrees centigrade atmospheric temperature and about 75% relative humidity. When that threshold is reached, then we'll see what will happen. On my second relay module, the LED will turn on, and you will hear the pump running the fan running just to bring a cooling impact to the environment. So let me just warm my hands, and so that I first turn this and then touch it again and see how it will go about. So the temperature is at 24, relative humidity is about 87%. So at the moment my fan is still off. Quickly into it. Right, there we go. Oh, sorry, it's not turning on because my unit was not on, so that's why it was not turning on. So at the moment, temperatures are 25, humidity 84%. So you can see over here, the LED has turned on for the second module, indicating that relative humidity is above threshold, and equally the temperature. And as a result of that, this need to take control measure. So the fan is actuated here to cool the greenhouse environment. So that's that. When I leave it, it goes below that threshold, it will reset, and my fan will go off. Have a look on it. So the fan is still running. In a few minutes it will go off, and then you will see my LED there going turning off equally. And there we go. If you can hear the sound, the switching sound that was that occurred. And the next thing is on intrusion. So let me just swap my hand over the sensor, sorry, the PR motion sensor. Remember I said this sensor here is basically meant to detect motion. So when I swap my hand over there, you'll notice that my red LED here, which is security status LED, will go on, indicating that intrusion has been detected. At the same time, SMS sent to the farmer. For all these conditions, an SMS is sent to the farmer, and after sending the SMS to the farmer, then we display locally and even push the same data to cloud. The next thing is tank status LED. This one will measure the volume. At the moment, the volume of the tank is 0 centimeters cubic, and as a result of that, it will keep blinking at a frequency of about 5 seconds, indicating that there's no water in the tank. But now look, I want to intercept the tank, and then we'll see whatever will happen. One component that I forgot to show you is the flying fish soil moisture sensor over here. This sensor basically is inserted into the soil, and it has a comparator here. So basically an analog digital converter. So after measuring the analog value, then it's converted into a digital value, and with that we are able to calculate the soil moisture content within the soil. So at the moment I'm inserting it inside a dry rice grain just to give us some small value, and the value it's giving us now the value is giving us at the moment is that the percentage soil moisture content is about 1.07%. That's the current value it's giving us, because it's inserting the dry rice grain. So when I just intercept the ultrasonic signal, then it will detect that there's enough water in the in the tank, and as a result of that, we'll automatically initiate irrigation, because at the moment there's no enough soil moisture in the soil. So when I just intercept the tank, I'll not use water, but I'll use my hands just to intercept that signal, so that the distance travel is very small, and so it will sense that there's enough water in the tank, and as a result of that, you will see my first module, the LED of the first relay module will go on, and then my pump will equally go on. So have a look. So there we go. Just checking on the dashboard the volume of the tank. Yeah, the volume has now risen to 402 centimeters cubic, and as a result of that, you at least you got to hear the sound, the clicking sound, meaning that the switching was taking place. The 3.3 volts supplied to the module to turn on the relay, so that my pump may go on. And just a minute, I can't hear the sound of the tank, so let me just switch it on, and there we go. You can hear my tank is actually running. Sorry, my pump is actually running, and that will allow us to irrigate the environment. So in a scenario where maybe soil moisture is still low, but there's no enough water in the tank, then what will happen is this: the pump will automatically turn off, because irrespective of whatever happens, we don't want the pump to run dry and waste energy supply. So when there's no water in the tank, for example, now the volume has returned to zero, we will realize that the pump will go off, and as a result, this will equally turn off. And so that's how interesting it works. Everything automated. You don't need manual intervention of anybody or human being. And the same happens through my dashboards here. Whenever all these conditions occur, then automatically this displays on my dashboard. Things are sent to the cloud, and everything is well taken care of. So as a farmer, there's no stress of worrying of mechanized or of manually operating all this and all these equipment. Whatever you need to do, just sit from far and have to monitor whatever is happening within your farm. Everything is taken care of, everything is automated. The last thing I forgot to show you was that one for another component here I have that allows me to measure atmospheric soil moisture, soil temperature. It's called DS18B20 sensor. This sensor basically can be dipped into the soil, and as a result of that, it can measure the soil temperature. The good thing with this kind of sensor is you can have as many as possible, and then do your sampling across the entire farm, and after that you can carry out some calculations just to find an average soil temperature for the entire farm. So that's equally there. When you, for example, when I hit it on my laptop, then the temperature will automatically rise, and all these things are displayed real time in the Thingsboard cloud. A minute, let me show you how Thingsboard cloud looks like. and the dashboards we've had. Let me just try to turn over my laptop towards the camera. The challenge is having this display, but at least we can have a small view of the same of the dashboard. So that's just how the dashboard looks like. The first dashboard, allow me to use the mouse. The first in the dashboard, okay. The first in the dashboard here is just a time series table, which basically shows me the measured parameters for each of those conditions. At the moment, I'm finding air temperature of 23 degrees centigrade, and then relative humidity of 58. We have a Celsius soil temperature of about 25, luminous intensity of about 485 candelas, and that's why my lamp is off. Analog soil moisture content, which we use to get the percentage of soil moisture, which now is about 0.4%, and then water volume is 0. But the moment I intercept that, you will notice that the water volume will automatically drop. Have a look at the other dashboards I have. Over here I have an alarm dashboard. At the moment, all the alarms have been cleared, so we can't see anything on the alarm dashboard. But when we instigate an alarm, we will be able to see that. The next thing here is atmospheric temperature, which currently is at about 23 degrees centigrade, and over here is relative humidity. These things change real time. For example, let's simulate for relative humidity. Allow me to touch onto the DHT sensor and have a look at what happens on that dashboard. You will notice that it will rise from 59% to a higher value, and the same will be happening to the temperature. And with that, it will be able to even turn on my fan, that is. So now it's at 75%, 76%. The temperature is relatively low at about 24. So as a result of that, the pump is still off. The fan is still off. It's now at 78%, if you can see. So that's that. Let me show you the dashboard for atmospheric temperature. It's now at 25 degrees centigrade. Here it is. As you can see, it's reading 25. So it's risen from about 22 to 23 degrees centigrade. So that's that. Quickly onto other dashboards. Extending this screen, so it's disappearing. Just disconnect that. Now back onto the other dashboards that we have. We have this one for soil soil temperature, which is currently reading about 25 degrees centigrade. I've just expanded that so you can see it. The next one is down here. This is for this one is for displaying the luminous intensity. It's now about 533, which is about 3. When I cover it, it will fall to a low value, and as a result of that, you will see this lamp going on. It's now fallen to about, you can see over here, 154 candela, and as a result of that, you can see my lamp has actually gone on in order to light up the greenhouse. It's now 53. When I remove my hand, you will see it rise up to higher value, higher than 300, and as a result of that, then the lamp will equally go off. It's now 523. Look at what happened on the lamp. The lamp will switch off in a second. Yeah, there we go. Next is some time series charts here, line charts. This one basically displays it's a line chart displaying the EHT11 and the temperature and humidity sensor together with soil moisture, soil temperature. So that's how it's real time actually. The next thing is this one here, soil moisture and temperature sensor. So the soil moisture and temperature sensor is this one here. You can see at the moment the soil temperature is about 24 and percentage soil moisture is about 39%. 0.39%. Over here into tank volume dashboard, which equally gives you the volume of the tank. Currently it's 0. Intercepting that will make it rise to a higher value. Have a look. And there we go. The pump has actually gone on because and have a look. It's now 351 centimeters cubic, and that's why my pump actually went on to irrigate the farm. That is that. The next is a bit of analytics. Now we are able to get data real time from our device and then now display them on, for example, tables. For example, here I can view for the last 3 months, and you will see that I'll be having all the data. It's still loading. I'll be having all the data for that period on a daily. I've filtered by day, so as a result of that, on a daily basis, you're able to see the soil temperature values that were measured, which averages to about 22, that is for 16th, 23, 18th, and then today it averages to about 22 degrees centigrade. So we get an average for the entire day and display it on that table. The next one is average daily atmospheric temperature table over here. Again, for this you can filter for the last 3 months, and here it is. It's loading. So you can see atmospheric temperature was about 23 degrees centigrade, and then that is for 14th, 15th about 22, that is 15, on 16th 23 degrees, and then today it's averaging to about 22.5 degrees centigrade. So with this will give you rich data to allow you to then make decisions on certain operations that you need to perform within the tank, within the farm. And remember, all these things, all these dashboards are downloadable, so you can export it and now based on the format you want for reporting purposes, or just for further analysis within on your local machine, and with that you are able to even make better decisions. Just a minute, my dashboard is hanging. Let me refresh. So let me just get back to where we were. So this is where we were. Let me just scroll it up. So this other one is for daily tank volume table. So this one just gives you the amount of water that was consumed. I can filter for the past 3 months, and then we have a look on the daily average. For example, this was 502 and that is on 16 centimeters cubic. On 20th it was 1,307 centimeters cubic, and then today 1,256 centimeters cubic. So all this allows you to gives you very rich analytics on the conditions of the farm and even the actions that are taking place within the farm. Connection is a bit poor. Just refresh it again. So the same will happen for LDR, that is light dependent resistor. Equally, we are able to tabulate the daily average for the luminous intensity within the farm, and that's that. So again, we over here we have a trend, basically a bar graph displaying the number of the various conditions that we have in the farm, right from relative humidity, luminous intensity, soil temperature, we have percentage soil moisture and the likes. So you can actually filter out. At the moment I have all the bars, but if you decide, you may come over here and just click on whatever you want to filter out. You will be left with the rest of the graphs. It gives you very dynamic graphs for reporting purposes. So that's that. And then the next thing is a line trend, equally for all these conditions that we are measuring, that can allow you to quickly have a visualization of the condition of the farm for reporting purposes. And here it is. The moment is not displaying because of the filter. Allow me to apply my filter and you'll see what the trend is like. Let's say I do for the past 3 months. This is what we have in our filter. So you can see it's giving you a line trend for all these parameters that we are measuring. So based on whatever you want to report on, you will just come over here on the legends and then filter out. For example, you can filter out luminous intensity by clicking on it like that, so that you can even remain with one line graph, or have a number of line graphs just for the sake of comparison, to be better, in order to better report on the conditions of the farm. So this one actually trends luminous intensity, relative humidity, soil atmospheric temperature, soil temperature, soil moisture, percentage soil moisture, soil temperature, and even tank volume. So that's that. Down here again, I had just a heat map that gives us the daily amount of water that has been consumed. So if we pick, for example, for the last 3 months, then we filter by day. Then we'll end up with some cool heat maps charts here. For example, you can see here, this is the month of August. Let me expand this. This is the month of August. On the date 14th, 4,977 centimeters cubic were used. This other date, that is 15th, 4,575. Today, 1,257. So with that again, you're able to remotely monitor the water or the tank volume in your irrigation system, and that's it. And remember, all these things, all these are trended, or we trend all these from using the data that we get from our telemetry. So when you come to my device over here and then you look at the latest telemetry, then you will notice that the system automatically gets data real time from the telemetry, and then use the same data in order to plot. And equally, we save the same data. That's why we are able to even train for the previous periods of time. So onto the microcontroller, onto the maybe the code, just to quickly show you how it looks like, and even the memory, just to see how we measure these parameters and stream real time to cloud. So quickly, allow me to open my ID. The other thing I forgot to mention to you is the functionality, the mailing functionality of this system. This system is able to send email notification real time to the farmer based on summer conditions that we set for the alarms. For example, if relative humidity and temperature goes beyond 75 degrees centigrade, 75% for relative humidity and 25 degrees centigrade for atmospheric temperature, then the fan will go on to just cool the environment, and at the same time the farmer is notified of whatever is happening. They will be told of they'll get a notification like this. For instance, let me just show you one here. This is for relative humidity. You are being told IoT smart farm device DH11 sensor has an acceptably high relative humidity of 79%, fan turned on, and this occur real time. I just disabled the alarm, the mailing functionality, because it was a bit spamming, and the number of the allowable number of emails that you can do was so limited, so I disabled this. But these are some of the historical email that I got on the same, and this even applies for the other conditions like temperature. For example, let's see over here. This is for temperature. You will notice here it's telling me the subject device IoT smart device soil temperature unacceptably high, and then with that it goes ahead and give me the soil, the atmospheric temperature, and even the action that is being taken, which is the turning on of the pump, so that it can cool the environment. The same will apply for even tank volume. So when the tank volume is high, there's no water in the tank, and then the pump will kick in. So there's no adequate soil moisture in the soil. Pump will kick in to just irrigate the farm, and as a result of that will be recorded, and the farmer is not equally notified on the email. So the last thing was to just show you on the ID how things stream real time to the cloud. I'm just trying to open it. So with this manual operations completely eliminated, the farmer can just monitor from remote and get to know whatever is going on within the farm without necessarily attending to the farm. My ID is taking time to load. Remember, this consists of both the hardware bit the software. So the hardware is whatever you can see, basically the prototype you can see on the table, but it runs behind the scene. We have the hardware that's uploaded, the software that's uploaded into the microcontroller you can see over here, and with that we are able to do all that control seamlessly, as though everything is just automated, but it's actually powered by the software that runs on this microcontroller. So just to know as the IDE opens. It's really taking time. The code is a bit heavy, so just open a new ID. So maybe something I forgot to mention for you is the estimated 800L. This one allows us to equally notify the farmer of every state that changes in the farm, and whatever has been control action that have been taken to remedy the same. So for example, soil tank high, soil moisture low, pump on, intrusion detected, farm unsafe, such things, or humidity low, humidity high, temperature high, fan on. Such conditions, they are equally sent as a notification through the CIMI 800L to the mobile phone of the farmer. Over here again I have LCD display, so all those conditions equally display on this. So this is an end-to-end system. Whether remotely or locally, you are still able to monitor the conditions that is happening in the farm. And now quickly onto the software. This is what this is the code that runs. It's a bit elaborate, so I may not go over it all, but it's written in C++, which starts with the initializing or including built-in libraries, and then thereafter goes ahead to declare some of the variables or the pins of the controller we'll use, and then goes ahead to even initialize our variables. And after that we get into setup of the setup code that will be running just once as we start our code, and then finally into the loop that will run continuously. So the loop calls several other functions to be able to get, for example, the get functions that allow us to get data from our sensors and then send them to the cloud. So for example, we have get and send DHT data to ThingsBot Cloud. We have get and send ultrasonic data to ThingsBot Cloud, and several other loops. And then finally, we also have other loops that basically does the measurement of the conditions. For example, DHT11 sensor loop, and even PR motion sensor loop. And quickly down here at the terminal, when you look, then you'll be able to see whatever is happening. For example, here I'm collecting DHT sensor, DS18, 20 temperature sensor, soil moisture sensor, ultrasonic sensor, and LDR sensor data. And then after that, I push them to cloud and equally then display them on the terminal here. So for example, now the atmospheric temperature is 23 degrees, and the relative humidity is about 57 degrees, and as a result, fan is off. At the same time, ultrasonic sensor, the soil, the tank volume is at 0 degrees centigrade, and as a result of that, even the irrigation pump is off. We equally have this one for LDR. LDR is currently at 580 calendar, and as a result of that, our lamp is off. So this is a robust system. From the terminal, you are able to see whatever is happening. Locally, you can see from the LCD displays, and even remotely, you can send SMS to the farmer on the condition of the farm. Equally, as you noticed, we are able to see everything that happens on the dashboards that we have here. So even remotely, the farmer is able to see whatever is happening. Never forget, we have a mailing functionality that allows you to equally send email notification to the farmer on whatever is happening in the farm. Thank you for your audience. See you another time. Bye bye.